This is number one, finalist, week 7, I believe. Population density, scientific and engineering notation, question 1. And they say, what is the equivalent decimal form? And they give us a scientific notation here. So what I did was I wrote the form for scientific notation here. And I identified my A, and my A is 2.82, and my N is a -2. So since this is a -2, I'm going to shift it to make it smaller n times. So I take that 2.82 and shift it 2 places to the left here, making it smaller, and end up with 0.0282 for my answer. Number 2, what is the equivalent decimal number? So we have 2.31 there times 10 to the -4. I wrote A times X is equal to, then find my A and my N. Since it's negative, I'll shift it to make it smaller n times. So I shift it to make it smaller 4 times. And there's my final answer there. And part B for that, rounding it to 4 decimal places. So that's 4 decimal places there. Check digit is here. Rounding it to 4 decimal places is this number here. Number 3. We're multiplying. Notice the number of significant digits that equal the least number of significant digits in the number specified here. So it looks like here, we have 1, 2, 3, 4. So we have 4 here. So when I'm multiplying this out, I have those powers of 10 I put together. Then I have those numbers here, real numbers here. Multiply them together and I get 27.12833 times 8 and 4 is 12. That's that scientific form, notation form. So I pull out a 10 here, making this 2.72712.833 times 10 to the first times 10 squared. And we write that powers of 10 to be 10 to the 13. Now it's in scientific notation form. And then they want to see here in decimal notation. I multiplied it out here. Okay. So this 10 to the 13 essentially is just 1 with 13 zeros, and you can multiply it from there. Can you get that? And that's number 3. Number 4. We're dividing here. Least number of significant digits is 2. So I'll finish with 2 significant digits there. So I rewrote this here, the powers of 10. I divide here, and that's what I get when I divide it. And when I divide this, I get 10 to the fifth. Okay. And you see two significant digits, so I have 1.1 times 10 to the fifth for my answer for part A. And for part B, you multiply it out, you get 110,000 for your answer. And that's number 4. And this one here is number 5. Two cities are 111 miles apart, right in scientific notation. So I have 111 here, and I want to get that 111, get my A. This is the form for scientific notation. I will need to get an A and get an N. So I'll shift my decimal point so that it's between, that my A is between 1 and 10. So I shifted it 2 places to the left, and I have 1.1. How many times did I shift it? 2 places. Okay. A positive 2 places. So I end up with 111 times 10 to the second power. My answer. And this here, number 6, we write this number in scientific notation. So I wrote the form here for it. X equal to A times 10 to the n. I got to find my A. So I shift my decimal point over 7 places till I get to a number between 1 and 10. And it was 9.78. N is equal to 7, and my A is a 9.7. And I'll replace, and that's my answer in scientific notation. Number 7. Number 7 is right there. So number 7, multiple of 10 column. See that column, multiple of 10 column here. Answers come from reading a conversion table using a prefix column. So you get these numbers here using that conversion table. Whatever kilo comes up to be 1,000 from that conversion chart. So on. So we look at the chart from that conversion chart. We see the kilos 1,000, and that gives me the answer there. Okay. And then you take that, we convert meters to kilometers. You know that relationship there. 1 kilometer is 1,000 meters. Okay. Then we see milli here. We look at the chart. That's going to be 0.001 for the answer. And then we have to convert that into millimeters. So that relationship is that 1 meter is 1,000 millimeters. And that gives me 87,510 millimeters for my answer. Then I look at femto from the chart, conversion chart. It's going to be 1 times 10 to the minus 15, a very small number. Then we have to convert 87.51 meters to femtometers. So I'll put it in the bottom, 10 to the 15 here up top, and it gives me this number here, 8.751 times 10 to the 16 femtometers for my answer. Next one is mega. Mega's here. From the chart, conversion chart, we have it's 1 million. Then you want to convert meters to megameters. Okay, so 1 meter would be this much here. We multiply them together and we end up with this many megameters. So megameters is a very large unit. And that's my answer there. So nano's next. And so from the chart, it's 10 to the minus 9. Then they want us to convert meters to nanometers. So that's a conversion right there. 1 meter. Same thing as 10 to the 9 nanometers. And then multiply it out and you end up with this number here for nanometers for my answer. Okay. And it's basically the same thing for each one of these. You're doing the same thing over and over again. Each one of these. And then you get down to giga. From the conversion chart, it's 10 to the 9. And they want you to convert 8.751. 1 giga is here. And so many meters. Okay. And so 87.51 is going to be a very small number. Looking at J, H, and I, we're doing more of the same from the chart, conversion chart, but its pico going to be 10 to the minus 12. Then they want to convert everything to picometers. Okay. Okay. So we multiply out, and this is what we get for picometers here. And doing the same thing again here for hecto. From the charts, 100. So 1 hectometer here, one 1 over 100 meters. And we convert that to hectometers. We end up with 18751 hectometers. Okay. Let's go on to number 8. Okay. And number 8 is right here. Eight there. All right. This is the first one here. So you have the decimal form. They want you to find scientific notation. Then they want you to find engineering notation. So we have micrograms here. Okay. We convert micrograms into grams. So I have 1 gram is so many micrograms, and it gives me the answer in decimal form. That's your answer there in decimal form. Then you want it in scientific notation. So I take this decimal form, put it in scientific notation, and I shift my decimal point. So I get to a number between 1 and 10. And I shift it over 4 times. So my A is 1.07. N is a -4. There's scientific notation there. 1.07 times 10 to the -4. And then they want engineering notation. So I take this -4 and I take it down to a -6. So I have here 1.07 times 10 squared times 10 to the -4 times 10 to the -2. So the 1.07 times 10 squared is 107, and it becomes 10 to the -6, and that's my engineering notation. B, we have so many picometers. From the chart, we can see the equivalents here. Our unit rate, 1 meter is 10 to the 12 picometers. Okay. Divide out here, we end up with 8.64 times 10 to the -10 meters. So they convert it into meters here. Okay. And then they want a scientific notation. So that's in this form here, it is in scientific notation. Okay, then they wanted engineering notation. So I take this down to, so I have -10 to the -10 times 10 to the -2. And I put a 10 to the second power there. So 10 squared times 8 points gives me 864 times 10 to the -12. My answer there. And that's engineering notation. C, you have 765, and you want to convert that to meters. So I have 1 meter here in millimeters. 1 meter is 1,000 millimeters. So I multiply this out. 7.65 meters. My answer there. Okay. And so uh, next thing they wanted us to do is put in scientific notation. So I shift my decimal point one place to the right, and I have a -1 there. And my A is 7.65. So there it is, my answer in scientific notation. Then they want in engineering notation, so I go from a -1 to a -3. So I multiply by 10 to the -2 here, and I have a 10 squared there. And I end up with 7.65 times 10 squared, 765 times 10 to the -3. And that's engineering notation there. Okay. Number D, nanobytes. So 1 byte, 10 to the 9 nanobytes. So I'm converting everything into bytes. So 169 divided by 10 to the 9 gives me this really small number here in bytes. My answer. And that's in decimal form. Then they want in scientific form, so I shift my decimal point, so it's between 1 and 10. And I'm shifting it 7 times, so I have a -7 there. And my A is 1.69. And I plug it in here for my A and N. And there it is in scientific notation. Then they want to see it in engineering notation. I take this down to a -9. So I multiply by 10 to the -2 here. And I multiply by 10 squared here. And 10 squared is going to be 169 times 10 to the -9 for my answer there. And that one is D. Okay. What I did first here, go ahead and put it and convert to engineering notation, look up the prefix from the table, and then convert to scientific notation. Some are already engineering notation. Okay. So the first one I put in engineering notation. It's already engineering notation. 10 to the -3 here. And from the chart, conversion chart, 10 to the -3 can it's the same thing as milli, or milliwatts in this case, milli from the table. And then the third thing is the one in decimal form. So I have 7.54 times 10 to the -3 gives me this number here in decimal form for my answer. For part B, engineering notation. So I have to rewrite the original. The original here is to the -4. So I take it down 2. So I have -4. -2 will be -6. So when I multiply this out, I have 2.29 times 10 squared. And then I have times 10 to the -4 times 10 to the -2. Gives me 2.29 times 10 squared is 229 times 10 to the -6. And that's my engineering notation. And that gives me 10 to the -6, which corresponds to micro in the conversion chart. And then next thing they want to do is put it in decimal form. So I'm multiplying by, I have 2.29 times 10 to the -4. Gives me this number here. And there's my answer in decimal form. And for part C, I put it in engineering form. So I take that 10, take that down 1 to the 10 to the 9. So I have a -1 there, and I have a +1 here. And that makes this 10 to the 9th here, and 10 times 6.96 is going to be 69.6. And that's my engineering form. And if you look at the table at 10 to the 9th, that corresponds to giga. Then they want to see it in decimal form, so I multiply this out. And I get this in my decimal form. And that's part C. Oh, that's number 9. Number 9D. Okay. So here we have engineering form. It's already in engineering form. So -15, the multiple of 3. And 10 to the -15 corresponds to femto from the table, the conversion table. And then they want to put it in some decimal form. Decimal form here from the answer. Okay. That takes care of that one. Number 10. In the valley, that is 48,524 square miles, live 59,600 mice. What is the mice population per square mile? The density is going to be population per square mile. So we have so many mice, so many square miles here. So I divide and get a unit rate here per square mile. And I end up with 1.228 mice per square mile. My answer there. And then what is the rate in per square kilometers? Okay, so 1 square kilometer is 0.386102 square miles. So when I multiply, I'm converting here. Square miles cancel out. I'm left with square kilometers. I have so many mice per square kilometer. And I have here 0.474 mice per every square kilometer.